So folks, on the previous page we derived the law of sines and we stated it this way. I'd like to state the law of sines another way. So the first way is the way we've already done, where we said that the sine of angle A over A is equal to the sine of angle B over B, which is equal to the sine of angle C over C. This is the same thing as inverting each of these fractions. So another way you could give the law of sines is to write A over sine A is equal to B over sine B, which is equal to C over sine C. I hope these don't seem like two different formulas for you. I hope we can see that this is just, if I were to invert this fraction, I have this statement. If I were to invert this fraction, I'd have this statement. And ratios remain equivalent. Equivalent ratios remain equivalent even if you invert both sides of the equation. The next thing is, this isn't a huge issue, the direction solve the triangle means to find all three interior angles of the triangle and to find all three side lengths of the triangle. So in general, if I give you a triangle, whether it's a right triangle or not, if I say to solve it, I mean to find each of the three side lengths, in our case A, B, and C, little a, b, and c, and each of the three angle measures, in this case the measure of angle A, B, and C. Those are all capitalized. That's what it means when I say solve the triangle. The other thing, folks, is when I ask you to solve a triangle, please make an answer box for each possible solution to this. So each answer box should have all 6 pieces. I guess I should point out that sometimes when I ask you to solve a triangle, there will be more than one solution, or in some cases there will be no solution to that question, but oftentimes there will only be one solution, and we'll talk more about that in class. Okay, all of that said, we spent a whole video, a chunk of time, learning how to derive this law of sines. We came up with it. We've now stated it twice here. Let's go ahead and use the law of sines to try to solve this triangle. Okay. And in this case, we're given 3 pieces of information here. So let's go down. I'm going to follow my directions here, and let's construct our answer box where we want to find the measures of each of the 3 angles. Folks, I'm a little bit lazy here. I might just write A, B, and C. What I really mean is the measure of angle A, the measure of angle B, the measure of angle C. And we also want to find side lengths A, B, and C. But some of this information was in the given to this problem. So I told you that the measure of angle A here was 129 degrees. So this was given. And the measure of angle B here was 28 degrees. And we don't know the measure of angle C. And I was told that the side length B was equal to 1 inch. So this is that answer box that I was talking about, and we're going to find the 3 missing components here. We're going to solve for those and fill them in. Okay, so this is our first time doing a law of sines problem where we're trying to solve a non-right triangle utilizing this law of sines here, one of these 2 versions of it. And here's how I want you to think of it. I have these pairs of ratios that I can form. I could either group together these 2 ratios, I could group together these 2 ratios, or I could group together this ratio along with this ratio, setting up equations and solving for any missing components if possible. So what I'd like to point out here is that if we look at this first part of the law of sines, it says A over sine of A is equal to B over the sine of B. What I'd like to point out is that for this ratio and for this given problem, I know 3 of the 4 pieces. I know the measure of angle A, that's this value here. I know the measure of angle B, that's this value here. And I know that the length of side B is equal to 1. So let's go ahead and solve this expression for the missing component. The missing component is I don't know what the length of side A is. So if I were to take this equation and isolate the variable A, we get that A is equal to B times the sine of A all over the sine of B. Then what I can do is I can plug in my known quantities. So I know that B measures 1 inch, that the sine of A will angle A measures 129 degrees, and we're going to divide all of that by the sine of angle B, which measures 28 degrees. So let me plug that into my calculator and get a decimal approximation. So pulling up my trusty handy-dandy calculator emulator, I can go ahead and enter in, I'm going to put in the numerator 1 times the sine of 129, and oops, I better verify. Sure enough, I am in degree mode. Make sure you're in the correct mode. If not, I could go to Shift Setup and Adjust Modes, but I am currently in degree mode there. And then we press the over button to bring us down into the denominator. Always pay attention to where your cursor's flashing, and we can enter in the sine of 28, and again that's degrees. We're in degree mode. Hitting equals, we get that A is equal to a 1.65, maybe 1.66. So let's give a decimal approximation for A there. It's approximately 1.66 inches. Folks, one thing I didn't do in these directions is I didn't tell you where to round. When we do these problems in class on the board, for examples, I'm not going to worry about specifying rounding directions. Come an exam, I will give very clear directions about where to round, and when you work the MyLab math problems for this, I'll also give you very clear directions about where to round. At this point, though, we can go ahead and plug in what we found for the length of side A. It's about 1.66 inches. And I'll put my little approximation symbol there to remind me that that's an approximation. Okay. Now that we've found that, we now have 4 of the 6 components. I want to now look at that law of sines ratio again, and I want to point something out. What I'd like to do is maybe use the same B over sine of B is equal to C over the sine of C. So that's grouping together the last 2 ratios here to try to solve for missing components. But currently, what's the problem? Well, currently I know the length of side B, so I know little b. I know the measure of angle B, so I know I can compute sine of B, but I have 2 unknown quantities here. I don't know C and I don't know sine of C. Ordinarily, we might have to use some sort of version of our inverse trig functions to help us move forward, but because I know 2 of the 3 interior angles for this triangle, I can solve for the third using geometry. What do we know about the measures of A, B, and C? The measures of those 3 angles have to add up to 180 degrees. So I can solve for angle C by saying that's 180 degrees less angle A, less angle B, and in this case, what would that be? So that would be, that came out for me to be 23 degrees. So we now know that the measure of angle C is 23 degrees. This is helpful. We use this geometric fact. This is helpful because now if I look back over here at this pair of ratios from the law of sines, I know 1, 2, 3 of the 4 components, which means I'm able to solve for side length C here. So doing what we did before, I'm going to isolate the variable C. I'll do so by multiplying the sine of C to both sides. So that gives me C is equal to B times the sine of angle C all over the sine of angle B, which in our case is 1 times the sine of 23 degrees, all divided by the sine of 28 degrees. And so for my calculator, let's check that again. Let me scoot this over for ourselves. Let's see. So we would have 1 times the sine of 23 degrees, and we'll divide all of that by the sine of 28 degrees. Setting that up maybe a little differently than I did before. There's lots of ways to enter into these new fancy calculators. And so that gives me the length of side C, oops, that popped down, is about 0.83. 0.83 inches. Folks, I will point out that when I made this problem, I didn't actually measure these degrees here, and so those are slightly off, which is why perhaps the collection of answers doesn't seem to 100% match that picture, although we have, A is our largest angle and it corresponds to the longest side, but I guesstimated what all those angles would be, and for that reason we don't have a perfect picture to our problem. Okay, so what did we do here, folks? Let's recap this. We started off with this given triangle. Usually I won't give you a picture for these problems, and instead I just give you 3 pieces of information. I gave you, in this case, the measure of 2 angles and the length of one side. I went ahead and started constructing my answer box, including my given information, and then, as needed, I used my law of sines and I used my knowledge of geometry to help me find the missing components to this right triangle, and we've now solved it. I want to point out 2 last things. The first thing is, if I were to use the letter A to stand for an angle and the capital letter S to stand for a side, we could go classify this triangle up here that I sketched for you. We could go classify this triangle as I gave you an angle, I gave you another angle, and I gave you a side length here. So if we were to read that in terms of the letters, if I went clockwise, I gave you an angle followed by an angle followed by a side. So we could call this an angle side triangle. Or if you were to read it counterclockwise, we started with a side, then I gave you an angle followed by another angle. So we could read that as SAA. And that's what we're going to start doing as we classify these triangles. If that doesn't make a whole lot of sense to you right now, I'm not too concerned because we're going to get lots of practice with that in class. But I just wanted to start showing you the given information. We were given angle A here, we were given angle B here, and we were given side length B here. And so if we read this is an S, this is an A, this is an A, we're at side angle. Or if we go in the other direction, we've got angle side, so AAS. That will be important as we bring in more interesting cases of the law of sines, as well as when we get to our law of cosines. The last thing, folks, I just want to provide this reminder. This is a brand new topic. We use the law of sines for non-right triangles. So if we're working with a right triangle, we've got better tools, and we'll go ahead and continue using those better tools. We use the law of sines when we have non-right triangles. All right, folks, that's all I've got for you. I will see you next time.